Hello everybody. Today we're going to be talking about some membrane transport proteins, um, obviously that are found in the cell membrane, and obviously they're transporting proteins into the cell. And so more specifically today I want to talk about conformation change transport proteins, as well as the GLUT transporters that are going to be transporting glucose into the cell and out of the cell as well. So first of all, let's look at this image here that I have. As we can see here, this represents extracellular space, the space outside of the cell, the cytosol, the space inside of the cell. We've got the cell membrane, and then here we have our transporter that can bring things into the cell, like we spoke about a little bit previously. And so, like I said as well, we are going to be talking about GLUT transporter. So a GLUT transporter, this is a transporter that's going to be bringing glucose into the cell, as we can see here. And so let's jump right into it. As we can see here, the transporter, right now it's in a conformation that is open. Okay, so it's open to the extracellular space. So why is that important? Because this glucose right there, it comes from the extracellular space, comes from the outside of the cell, and it approaches this transporter right here, this GLUT transporter. Then what's going to happen next is the glucose is going to bind to the transporter. As we can see here, the glucose is in the extracellular space, and then it actually physically binds to this conformation, it physically binds to this transporter. And so why is it called a conformational change transport protein? This is exactly why right here. We can see that when the glucose is then bound to that transport protein in the membrane, the conformation of the transport protein changes. We see that here at the top, where it was previously opened to the extracellular space, it is now closed off, not allowing anything else to enter in at the time, and it is actually open there at the bottom to the cytosol, the inside of the cell. Once this occurs, that glucose is exposed to the inside of the cell. The glucose can then dissociate from the transport protein, which leads us to this conformation right here. Same conformation, we just don't have a glucose bound to the transport protein anymore. But what is going to happen as soon as that transport or that glucose dissociates from the transport protein? We're going to get the conformational change back to the original state. And so this is actually referred to as the rocker method, because it kind of rocks back and forth. It rocks between opening up to the extracellular space, to opening to the cytosol, and back to opening up to the extracellular space, ready to bind again. And so this rocker method is actually something that is extremely common in a lot of transport proteins in the membrane. It's a method that a lot of them use. And we were talking about, it involves the binding of a ligand. So the ligand is what binds there to the transport protein, causing the conformational change. And so to finish off today, I wanted to talk a little bit about some important things of the GLUT transport, some important facts about the actual conformation, physical conformation of the transport protein. So we'll get right into that. Okay, hopping back into the video here. Like I said, we're going to talk about some physical features of this GLUT transporter, this transport protein that brings glucose into and out of the cell. One thing that is extremely important about the GLUT transporters, it's actually made of 12 membrane spanning alpha helices. And so why is this important? Well, this is extremely important because those membrane spanning alpha helices, they create a hydrophilic pore, which actually allows the glucose, which is a polar molecule, to enter into the cell. If we didn't have that, the glucose physically would not be able to enter through that hydrophobic part of the membrane. This GLUT transporter creates the hydrophilic pore in the membrane, allowing the polar glucose to enter in. So that's extremely important. Another important fact here is that these actually act like enzymes. And so when they bind glucose and they have conformation changes, they actually act like an enzyme in the fact that they can speed up how fast a molecule can or a protein can come into the cell. And so it's a lot like an enzyme in that way as well. So something extremely important to note there. And yeah, that is all we're going to touch on today for glucose transporters. Thank you so much for tuning in.